G'day. Can you find the derivatives of products of functions in just 20 or 30 seconds or even less? If you can't, then you need to watch this video. In it I'm going to first of all demonstrate how it's done, then I'll show you the basic theory behind it and how to learn it and how to put it into practice. Here I have behind me six examples, six equations where we have a product of functions in every case. They're from the New South Wales Higher School Certificate in Australia, which is the basic level advanced course for school leavers. And these are questions towards the beginning of the paper, so they're easier questions, worth 2 marks each, and therefore the time allocation is about 3 minutes per question. We're going to first of all solve them without much discussion, and I'm going to demonstrate the kind of speed that you should be able to achieve in your HSC examination or whatever examination you're sitting for around the world. Let's have a look. The derivative of this product is the derivative of that, x minus 1, and the derivative of that of course is 1, times the log x, plus, leave this alone, multiplied by the derivative of log x. 1 times log x of course is log x, and x minus 1 times 1 is x minus 1 over x. So we have the derivative stage and then the simplification stage. Now you can time this. I'm certainly not going to take 3 minutes per question, and with practice you should be able to do the first step in about 10 seconds and then use another 10 seconds or so to simplify the expression or the equation. Derivative here will be 2x times tan x plus, leave the x squared alone and multiply by the derivative of tan x, which is sec squared x. And in fact you really can't simplify that much beyond taking x out as a common factor. The derivative of this one will be 2x times log x plus x squared times 1 on x. Simplification, 2x log x, and one of these x's will divide out, leaving you just a simple x. By the way, this was the 2012 HSC question, 2010 and 2008. Here's the 2011 question, plus x squared e to the x. That's worth 2 marks. It's supposed to take up to 3 minutes. I think we took about 10 seconds. This one here, the derivative of x is 1 times sine x plus x times the derivative of sine x is cos x. And the only tidy up you need is we normally wouldn't write 1 times sine x. That was worth 2 marks. This one here, the derivative of x is 1, so it's 1 times tan x plus x times the derivative of tan x is sec squared x, which is tan x plus x sec squared x. Now I suspect that took us about 2 minutes to complete the page. If I didn't have to talk, we'd probably reduce that to not much more than a minute for all 6 questions. What I propose to do now is to explain the theory behind this very quickly, then show you a simple structure that you should memorise that will help you be able to solve all these equations, or at least find the derivatives for all these functions, and then I'll quickly demonstrate a few examples afterwards, large examples as well, so you understand the principle very thoroughly. So what are the foundations of the product rule? For school students in my state, in Australia, there's 6 basic functions. They must be able to find the derivative of x to some power, which is the foundation of all polynomials. They must be able to find the derivative of an exponential, the derivative of a logarithmic function, the derivative of a sine function, a cosine function, and a tangent function. If you can write a summary of all these 6 functions and their derivatives, then you've already established the foundation for using the product rule. The derivative of x to the power n is nx to the n minus 1. That is, the index comes down the front and then it's reduced by 1. The derivative of the exponential is itself. The derivative of the logarithmic function is 1 over x. The derivative of the sine function is cosine of x. The derivative of the cosine is minus sine x. And the derivative of the tangent is sec squared x. Now, how does that work with the product rule? Well, let's make a product of some of these functions. Let's write y equals, let's say, e to the x times sine x times log x times tan x. Now, each of these individual functions are not complicated. I'll deal with that in another video. But we do in fact have a product here of 4 functions. Let's look at the derivative. When I was at school, I was taught how to find the derivative of a product of 2 functions. We called them u and v, and then the derivative was u dash v plus v dash u, and I find that students get confused with that. I want you to see the pattern simply as a structure on a page, and here it is. The derivative of this is the derivative of e to the x times the remaining functions. If you like, this is our u dash v. Plus, then we move to the next function. We leave the e to the x alone, we leave the log x and the tan x alone, but we find the derivative of sine x, which of course is cos x. Then we move to the next function, which is the logarithm. We've done the derivative of the exponential, the derivative of the sine function. Now we work on the derivative of the logarithmic function, and we leave the other 3 alone. So I'm going to leave them in blue. The derivative of the logarithmic function is 1 over x. And then the final step is to move across to the tangent function, seeing as we've already done the exponential, the sine and the logarithmic functions. We'll find the derivative of tan and leave the other 3 alone. And the derivative of tangent, of course, from our little summary at the top, is sec squared x. Believe it or not, that is the derivative of that compound function. The product rule, as you see, when you get past a product of 2 functions, looks a bit like a grid or a matrix with a diagonal composed of the derivatives of each of the functions. So if you had 6 functions, you would have 6 separate expressions all added together, and in each expression everything would remain the same except that one of those 6 functions would be replaced by its derivative. I'm going to do that one more time, and then we're going to look at how to apply that to smaller and simpler examples. So let's try a different function. We didn't use a power of x before, so let's do x to the 5th. I don't think we used cosine function before. Cos x, e to the x, sine x. Let's make it tan x as well. Here we have 5 functions, so I think you will appreciate that we're going to have 5 steps underneath. The derivative is going to have 5 lines, which I'll try and write very quickly. In fact, let's write the blue material first. We're going to first of all work out the derivative of x to the 5th, so we're going to leave the cos x, e to the x, sine x, tan x in place. looks awful. There we go. It's not much better. Then we're going to leave the x to the fifth in place and work out the derivative cosine of x and leave the e to the x sine x tan x. Then we're going to leave the x to the fifth cos x. We're going to work out the derivative e to the x and leave the sine x tan x. Then we're going to work out the x to the fifth cos x, e to the x, and the derivative sine x will go here, and then we'll have tan x. And finally, x to the fifth cos x, e to the x, sine x, and the derivative tan x. So we've now got our 1, 2, 3, 4, 5 lines all prepared for the derivative. The derivative of x to the power 5 is 5x to the 4 times whatever's left, which we've already written. The derivative cosine of x is minus sine x times the remaining 4 functions. The derivative of e to the x is e to the x, and we've left the remaining 4 functions to be multiplied by it. The derivative of sine x is cosine of x, and the derivative of the tangent of x is sec squared x. And that is the derivative of that function. That's the product rule in action, without using substitution, without u-v's and v-u's. That's it. So I'm going to clear the board now, and in the remaining minute or two of the video, we're going to look at perhaps 4 examples and see how we use this particular process to find their derivatives. Well, I've decided to find the derivatives of 5 functions instead of 4, and here they are. When we've worked through these, I'd encourage you to go back to the beginning of the video and stop when you wish, but look through the first 6 examples that I gave from higher school certificate examinations in my state in Australia, and see this process in action on those questions. But here we go. The derivative is the derivative of the product of these functions. So we do the derivative of this function first, which is 5x to the 4, leave the e to the x alone. Then we leave the x to the 5 alone and do the derivative, or find the derivative of e to the x. Now, of course, you could, if you wished, take out the common factor of x to the 4 e to the x. And this would leave 5 plus x, or x plus 5. This one, the derivative, we have a sine function times a logarithmic function. The derivative of sine is cos x. Leave the log alone. I write underneath the next expression. We leave the sine function alone, and we find the derivative of the logarithm, which is 1 on x. I'll just leave that as it is. This derivative, cosine times an exponential. Derivative of cosine is minus sine x. Leave the exponential alone. And then we add on the cosine of x times the derivative of the exponential. So the first time around we do the derivative of the cosine. The second time around we do the derivative of the exponential function. Here we go. The derivative of this product will be the derivative of x to the 4 times the remaining tangent function, plus leave the x to the 4 alone, and the derivative of tan x is sec squared x. And finally, I decided to add this one, which is a product of 4 functions. So we're going to have 4 lines. The first one, derivative of sine, is cos x. Leave the rest alone. And you can see that with time you can do this very, very quickly. And now I find it helpful to point with my finger. So we've dealt with this. The next one we're dealing with this. So we leave the sine x alone. Derivative of e to the x is e to the x. Log x, x to the 7. Moving across, the next one is sine x e to the x. Derivative of log is 1 on x times x to the 7. And then the final one, we leave the first 3 functions alone and find the derivative of x to the power 7, which is 7x to the 6. Now, of course, when one tidies this up, this little product here could be simplified. The x would divide into x to the power 7 and create x to the power 6. There are some common factors you could take out, but I'll deal with that in another video. But here I've just concentrated on showing you how to find the product rule, or how to find derivatives using the product rule, and I hope that's made sense to you. Let me encourage you to practice using examples from your textbook or from the internet or wherever you can obtain them, past exam papers. Pester your teachers until they give you pages and pages of them, and practice them until you can actually solve these, until you can find these derivatives in at least 10 or 20 seconds, and hopefully even less. So if you can find these derivatives at the rate of 3 or 4 per minute, then you can appreciate that every few weeks or every few months you can pull out an exercise of them and do 20 or 30 or 40 examples in a matter of 10 minutes, and that is very, very good practice. So I hope that's been of use. Please leave a comment, like this video, and by all means subscribe so you get to hear about or get to find out about the new videos that I'm producing. Thank you for watching.